Okay, so let's use joint analysis to solve and determine the force in each member of this truss. Okay, so I have this truss. I have two forces, 800 and 600. Okay, now you remember the first place to start is at a joint that has at least one known force and no more than two unknown forces, which is joint C. So we'll start at joint C and draw a free body diagram. Okay, so I have my external force, my 800 force, located right here. And then I have CD and BC that I have drawn right here. And these are drawn in compression because it looks to me like the forces will actually be in compression. A lot of times I'll just assume things are in tension, but in this, the book that I'm taking this from assumed compression. That's fine. Whatever you want to do is fine. Typically, as I go through them, I assume tension. Okay. Regardless, I know their direction are directed along CD and BC, so I draw those forces. Again, these are drawn in compression. This is my free body diagram for the joint on C. Okay. So now I simply sum the forces in the x and y and set them equal to 0. So if I sum the forces in the x, I get this 800 cosine 60 going in the negative, and I have FBC going in the positive. So I have FBC minus 800 cosine 60. That equals 0. Those are the only two forces in the x direction. Solving for FCB, and I get 400 pounds. And again, I get a positive answer, which means that my assumption over here is correct. So FCB is in compression, as I have it drawn in the free body diagram. So it's pushing on that pin, okay, under compression. I also sum the forces in the y direction, and I have FCD acting straight up and 800 sine 60 acting down. So FCD minus 800 sine 60 equals 0. Solving that for FCD, I get a positive 693 pounds, meaning my assumption that the member CD is pushing up on joint C, meaning that it itself is under compression, is correct. So I write this as 693 pounds under compression. Okay, so now I know CD, I know BC. I can go over to joint B now, and the only two members I don't know are BD and BA. I know this is 600, and I know BC is 400. I just solved that. So I can go on to B now. So I look at joint B. Here's my free body diagram for B. Again, I have 600 known, and that's going straight down. I have 400 in compression for member CB. So I have that going into the joint, acting to the left, into the joint. Okay, pushing on joint B of 400. And then I have my FBA. Here I've assumed it in compression. So I assume it's pushing on joint B, pushing up on joint B in compression. And I have FBD, which I assumed is in tension. So I assume BD is pulling on that joint because it's being stretched out, pulling on the joint, drawing the free body diagram of the joint. So tension moving out. Okay, and that's my free body diagram for B. So I've got these two known forces, the 600 and the 400, and then the two unknown forces, BA and BD. Now I simply sum the forces in the x, sum the forces in the y, set them equal to 0. So in the x direction, I have my FBD. That would be 3/5 FBD going in the positive x direction, and I have 400 going in the negative x direction. One's going to the right, one's going to the left. So 3/5 FBD minus 400. And that tells me FBD equals 667. I get a positive answer. My assumption that it was in tension is correct. So it's 667 pounds in tension. FBD is pulling on joint B, and it itself is being pulled by joint B in tension. Summing a force in the y direction, sum equal to 0. I have the 4/5 BD going down, which is that 667, which I just solved. I have FBA going up, and I have 600 going down. So FBA is going up, minus 4/5, 667, because that's going down, minus 600, because it's going down. Set that equal to 0. Solve for FBA. I get 1133. Again, that's a positive value. So my assumption that FBA is acting upward, therefore it's in compression, going into the joint. Okay, FBA can be written as 1.13 kips in compression.